Hello viewers. So in this session I am going to solve numericals on first application of dimensional analysis for you. Okay, so we were discussed about first application of dimensional analysis. I hope you know that is to convert a physical unit from one system of unit to another system of unit, to convert a given physical quantity from one system of unit to another system of unit. So that is our first application in dimensional analysis, right? And we have already converted 1 Newton into dyne and 1 joule into erg, right? So in this session I have one problem. So here also I have to convert from one system to another system. They have not given that system, okay, but one system to some new system of units, okay. So let me read the problem what they have given here. So when 1 meter, 1 kg and 1 minute are taken as the fundamental units, okay, the magnitude of the force is 36 units. What will be this value of force in CGS unit? Look here, 1 meter, 1 kg are the units in MK system, right? Are the units of length and mass in MK system. But instead of they have to give second here, instead of giving second they have given minute here, okay. So here we have to convert these new system of unit to some other system of unit, or this system of unit to some new system of units, okay. So we have to follow the same procedure to convert a given physical quantity from one system of unit to another system of unit. So they have mentioned force here. So we have to convert this unit of force into new system of units, that is dyne itself, right? In CGS system the unit of force is dyne, okay. So if you don't know the unit in CGS system, then you have to write new system of units there, okay. That's more than enough for you, okay. Then so let me consider, let Newton is the unit of, is the SI unit or MK's unit of force, and dyne, if I know, then I have to write this sentence. Dyne is the unit of force, is the unit of in MK system, sorry, in CGS system, okay. I have already told you how to solve this problem, and we have a particular formula to convert a given physical quantity from one system of unit to another system of unit. Hope you have remembered that formula. So here I am going to use that formula to solve this particular problem, okay. Okay then, so let me divide MK system and CGS system here. See, one more time I have to read the question so that I can able to write the things whatever will get in the left hand side and the things whatever in the right hand side, okay. So 1 meter, 1 kg, 1 minute are taken as the fundamental units of the magnitude. So it all comes in the left hand side in MK system. Of the force is 36 unit. So N1 is equals to given here, that is 36 unit. What will be this value of force in CGS unit? So I have to find these values in CGS unit, okay. Then so in MKS unit we have N1 is equals to given 36 and M1 value is given, that is 1 kg, and L1 is given, that is 1 meter, and time T1 is given, that is in terms of minute here, okay, minute, okay. And in CGS what is the value of N2 that I have to calculate, so put question mark there, and M2 is mass in terms of gram, write 1 gram, and L2 is 1 centimeter here, and time t2 will be 1 second. Okay, hope you have remembered this formula to calculate the value of n2, because we have already discussed that formula in our previous session. Okay, then so I am going to apply that formula here. N2 is equals to n1 into m1 by m2 raised to a and L1 by L2 raised to b, okay, and T1 by T2 raised to c here. So what are the values of ABC? So they have given the force here, so I have to write the dimensional formula of force. Okay, so the dimensions of force will give you the value of A, B, C there. So dimensional formula of force is m raised to 1, L raised to 1, T raised to minus 2. So therefore we have A is equals to 1, B is equals to 1, C is equals to minus 2. Okay, so now I am going to apply the values of m1, m2, l1, l2, t1, t2 and abc n1 directly to that expression to find the value of n2 here, or to get the value of n2 here. So n2 is equals to, n1 is 36, so let me write 36 here. And what is the value of m1? m1 is 1 kg divided by 1 gram. Okay, so m2 value is 1 gram. Okay, then so here L1 is 1 meter divided by 1 centimeter into T1 value is 1 minute here, so I'm writing 1 minute divided by 1 second, or 1s, 1 second. Then I have to put the values of A, B and C. A is equals to 1, B is equals to 1, C is equals to minus 2. So A is equals to 1, B is equals to 1 and C is equals to minus 2 here. Okay, so now let me simplify this expression what I have. Okay, 1 kilogram is equals to 1000 gram divided by 1 gram into 1 meter is equals to 100 centimeter divided by 1 centimeter, and 1 minute is equals to how much second here? Okay, this is raised to 1, this is raised to 1. Okay, 1 minute is equals to how much seconds? 60 seconds. We all know the basic things. So 60 seconds divided by 1 second, that is raised to minus 2. Okay, so now I am going to cancel the terms which are cancelled out here. So a gram, centimeter, second gets cancelled. Okay, so therefore this implies, okay, n2 is equals to 36 into 1000 into 1000 raised to 1, 100 raised to 1 and 60 raised to minus 2, 60 raised to minus 2. Okay, so this can be written as n2 is equals to 36 into, for 1000 in terms of powers it would be 10 cube, and 100 can be written as 10 square. Okay, and 60 raised to minus 2 can be written as 1 over 60 whole square here. Okay, 1 over 60 whole square. So therefore n2 is equals to 36 into, okay, so this is 10 cube plus 10 square is 10 raised to 5. Okay, so if 10 cube into 10 square, 10 raised to 3 into 10 raised to square ಇತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ ಅದರ ಪವರ್ಸ್ನ ನಾವು ಏನು ಮಾಡ್ಬೋದು, ಆ್ಯಡ್ ಮಾಡ್ಬೋದು. ಸೊ ಯು ನೋ ಹೌ ಟು ಡೂ ದಿಸ್. ಸೊ ಡೈರೆಕ್ಟ್ಲಿ ಐ ಆಮ್ ರೈಟಿಂಗ್ ಹಿಯರ್ ಇಟ್ ಇಸ್ 10 raised to 5. Okay, so this is divided by 60 square. So this is equals to 36 into 10 raised to 5 divided by, so here you are having 60 square, so you should have to do 60 into 60. So 60 into 60 ಮಾಡಿದ್ರೆ you will get 3600 ಬರುತ್ತೆ ಅಲ್ವಾ, 3600 ಬರುತ್ತೆ. ಸೊ ದಿಸ್ ಕ್ಯಾನ್ ಬಿ ರಿಟನ್ ಆಸ್ n2 is equals to, ಇದನ್ನು ನಾವು ಯಾವ ಥರ ಬರೀಬೋದು ಅಂತ ಹೇಳಿದ್ರೆ 36 into 10 raised to 5 divided by this 3600 can be written as 36 into 100 is 3600. So for 100 we'll write 10 raised to 2. So 36 into 10 raised to 2 anta barutte. So 36 gets cancelled. 10 raised to 5 divided by 10 raised to 2 ide. If it goes to the numerator, it becomes 10 raised to minus 2. So it becomes 10 raised to 5 into 10 raised to minus 2. So therefore N2 is equals to how much here? 10 raised to 5, 10 raised to minus 2. 5 minus 2 is 10 raised to 3. So 10 raised to 3. If you know the CGS unit of force, that is dyne, then you can write directly there 10 raised to 3 dyne. So here we have to convert 36 unit of force, which is in the fundamental units, into the new system of unit. Suppose if you don't know, then you have to write it is 10 cube into new system of unit. Okay, clear? Okay then, so this is the problem on applications of first applications of dimensional analysis. Clear? Okay, now let's move on to the numericals on second application of dimensional analysis, what I have done for you in the previous session, that is to check the correctness of the equation. Okay, suppose if the equation is dimensionally correct or not, if I want to check whether that is correct or not, then I have to check it dimensionally, right? So to check the correctness of the equation, we use dimensional analysis. So that is the second application of dimensional analysis we have. Suppose if the examiner asks you, or in examination you'll get a question like this: check the correctness of the equation T is equals to 2 pi into root of L by G, where T represents the time period, and L represents the length, and G is the acceleration due to gravity. G is the acceleration due to gravity. So this is one numerical based on the second application of dimensional analysis we have. So here you have to check whether the given equation T is equals to 2 pi into root of L by G is correct or not, and they have mentioned where L is length and G is acceleration due to gravity and T represents the time period. Okay, so here I have to check whether that equation is dimensionally correct or not. Okay, so with the help of dimensions only I am going to check whether that is correct or not. Okay, so first let me write the given equation T is equals to 2 pi into root of L by G, and I know where L is the length, G is the acceleration due to gravity, and T represents the time period here. Okay, so here I have to see whether the left hand side is equals to the right hand side. If the left hand side of the equation is equals to the right hand side of the equation, then I can say that the given equation is dimensionally correct. Otherwise, if left hand side is not equal to the right hand side, then we'll write the given equation is dimensionally incorrect here. Okay, okay then. So first let me consider the left hand side of the equation here. So LHS implies time period. So left hand side alli ನನಗೆ time period ಇದೆ. Time period ಅಂತ ಹೇಳಿದ್ರೆ it's a time itself ಅಲ್ವಾ? So time period. So for time period, the dimensions of time period is just t. Okay, the dimensions of time period is t here, and this is a constant value, so idನ್ನ ನಾನು consider ಮಾಡಲ್ಲ because it is a dimensionless constant. Okay, so here I have to consider this. Okay, right hand side. So right hand side of the equation contains square root of L divided by G, so which can be written as L to the power half divided by G to the power half. ಬರಿಬೋದಾ? ಈ ಥರ ಬರಿಬೋದಲ್ವಾ? ಸೊ L to the power half divided by G to the power half ಅಂತ ಬರಿಬೋದು. ಸೊ here ಇದನ್ನು ಯಾವ ಥರ ಬರಿತೀನಿ ನೋಡೋರಿ. L represents the dimensions here, right? L represents dimensions. So here or ಇದನ್ನು ನಾನು ಈ ಥರ ಬರೆದ್ಬಿಡ್ತೀನಿ raise to half ಅಂತ, because square root of L by G ಇರೋದ್ರಿಂದ L by G whole to the power half ಅಂತ ಬರಿಬೋದು. So here I have to write the dimensions of length. So length dimensions ಏನು? Just L, okay, divided by what is the dimensions of acceleration due to gravity. Acceleration ಆಗಿರ್ಬೋದು ಅಥವಾ acceleration due to gravity ಆಗಿರ್ಬೋದು. So both are okay having the same dimensional formula, so that is L T minus 2. okay, idra power half, whereas idu kuda power half ಆಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿ L raise to half, L raise to half ಏನಾಗುತ್ತೆ? ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಸೊ here you'll get 1 over T raise to minus 2 whole to the power half. ಆಯಿತಾ? ಸೊ ಇಲ್ಲಿ 2 by 2 ಏನಾಗುತ್ತೆ? ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಆರ್ ದಿಸ್ ಕ್ಯಾನ್ ಬಿ ರಿಟನ್ ಆಸ್ 1 by T raise to minus 1. ಸೊ 1 by T raise to minus 1. If I take this T raise to minus 1 to the numerator, it becomes T raise to plus 1. So T raise to plus 1, again it will give me just the value of T. Right? See the LHS. LHS is having only the time period which has the dimension capital T, and for right hand side of the equation also I got the same dimensional formula, that is capital T itself. So left hand side of the equation is equals to the right hand side of the equation here. So the given equation is dimensionally correct. So here I have to write one sentence that the given equation is dimensionally correct. Okay. So this is the numerical on second application of dimensional analysis we have. Okay. Okay. So now let me explain you about the third application of dimensional analysis, that is the third application of dimensional analysis is to derive a relation between